Hello student, welcome to our second lesson. In this lesson, we continue with the stability of isotopes of element, but here we look at types of radioactivity. Now we have two types, we have natural and artificial. Now when we come to natural radioactivity, this one occurs when radioactive nuclide splits spontaneously, yielding a new nuclide with emission of radiation and energy. In other words, this is a process that is occurring naturally. It is a radioactive nuclide that is splitting spontaneously, randomly, and it gives up a new nuclide which is having a different composition. And in the process, there is emission of radiation and energy. That is natural radioactivity. But when we come to artificial radioactivity, this one occurs when a large stable nuclide, note that the word is stable, is bombarded with a fast moving high energy particle. So in other words here, you have a stable nuclide which is very large, then you bombard it with a moving particle. You can use a neutron that is having high speed. Then when it strikes this stable nuclide, then this stable nuclide will split. So that way we say that we have made that radioactive artificially. So those are the two types. Now in the process, the nuclides split into relatively small nuclei with emission of energy and radiation. So in other words, both natural radioactivity and artificial radioactivity, there is emission of radiation and energy, or emission of particles and energy. Then we move to types of radiations. We have that when a radioactive nuclide disintegrates, or it splits, or it breaks up, they emit radiations. And these radiations can be alpha particles, or beta particles, or even gamma radiations. So these three gives us what we call the types of radiations. That is alpha, beta, and gamma radiation. So we move to the characteristic of radiations. One, we start with alpha decay or alpha particle. This one, it is positively charged. In other words, it is represented by a helium, this one. And as you can see, it has a charge of 2, positive. Then number 2, we have said that it is represented by helium and it is denoted by alpha. This is a Greek letter that is called alpha. Now this alpha particle has an electrical charge of 2 positive. As you can see, it is positively charged. Then this alpha particle is massive. In other words, it is heavy. When you compare it with beta and gamma radiation, this one is heavy. And because it is heavy, it moves with a lower speed in air. Then we come to beta radiation or beta particle. Now these are particles which are negatively charged, and they are represented by an electron, as you can see, and denoted by beta. Now they are electrons. In other words, we are saying they are electrons, but these electrons originate within the nucleus, not from the outer energy levels. Remember, at the first we talked of chemical reaction. The chemical reaction happens because of valence electrons that are in the energy level. But now the electrons that we are talking of, they are not coming from the energy levels. They are originating from the nucleus. Remember, inside the nucleus we have neutrons and protons, but due to instability, the reaction emits beta decay or a beta particle, which is an electron in nature, and it is coming from the nucleus. They are formed when a neutron changes into proton within the nucleus. Then from there, it is represented by this equation. You can see we have a neutron that is changing into proton, and when it changes into proton, it releases this electron. So we are saying that this electron is coming, it's originating from the nucleus due to this reaction. And this is happening because our nuclide is not stable. We have neutron, then proton, then electron. And as you can see from here, the sum on the upper part from this side, right hand side of the reaction, 1 plus 0 is 1, and on this left side is 1. Then this one is 0, but this one, when you add 1 plus minus 1, again you get 0. Remember, this nuclear reaction has to be balanced. So you have to check whether it is balanced. So the negative one represents the charge on an electron, this one, and not atomic number. So this one is not referring to the atomic number. It is representing the charge on an electron. So beta particles have an electrical charge of -1. Remember, alpha particle had an electrical charge of +2. Then from there we move to gamma radiations. Now these ones are high energy rays. In other words, they do not have any electrical charge. They are radiations. In other areas, we call them electromagnetic waves. They are waves that are just moving, so they carry no charge. And they are emitted. They cannot be emitted by their own. They always accompany the emission of alpha or beta. So it implies that if a radioisotope is undergoing decay, it can emit alpha, and that alpha is accompanied by gamma. So in other words, we are saying gamma radiations cannot be emitted alone. It always accompanies either alpha or beta radiation. Then from there we have the properties of emitted radiation. In this one, we start with the penetrating power. We start with the first particle, that is alpha particles. They have low penetrating power. In other words, they do not pass through a sheet of paper. So if you have a radioactive substance that is emitting alpha particles, and in their path you place a sheet of paper, it implies that those alpha particles cannot pass through that sheet of paper. They have a range of only a few centimeters in air. That is, they lose energy very fast. So as they move, their range also disappears because they lose energy very fast. Then we have beta particles. They have a higher penetrating power as we compare them with alpha particles. They can penetrate the sheet of paper, but they are stopped by a sheet of aluminium foil. So in other words, if you put a sheet of paper, they will pass. But if you put a sheet of aluminium foil, they can't pass. They are stopped. Then we have gamma radiations. This one, they have a very high penetrating power. They penetrate through the sheet of paper and through aluminium sheet. They are stopped by a thick block of lead. As you can see in this diagram, the first particle are alpha particles, these ones. This part is paper, a sheet of paper. The second one is aluminium foil, or a sheet of aluminium. Then the third one is representing a lead or a block of lead. So as you release alpha particles here, they can't pass through the sheet of paper because they have low penetrating power. But when you release beta, it will pass through the sheet of paper, but it can't pass through the aluminium foil. But for the gamma, which is just a radiation, it will pass through the paper, pass through the aluminium sheet or the aluminium foil, but they are stopped by lead. This is what we call the penetrating power of our emitted radiation. From there, we move to the second property, the deflection by an electric field. Remember, we have seen that these particles, some are charged and others are not charged. For instance, if we start with alpha particles, this one we say that it is positively charged, which implies that they are attracted by a negative plate. Remember, we always say that like charges attract. That is the law of charges, that like charges and like charges attract. In other words, we are saying it is positive and this is negative, therefore they attract. They are unlike charges. They are deflected slightly since they are heavy. Remember, we have said that they are massive. So as they move, they are heavy, and therefore it is very difficult to change their path. That is why they are just deflected slightly. When you come to beta particles, we have seen that these ones are negatively charged, and therefore they will be attracted by a positive plate. So when they are moving through a charged plate, they will be deflected towards the positive plate. These are again unlike charges. They will attract each other. They are smaller in mass. They are lighter as compared to alpha, and therefore their deflection is greater as they pass through charged path. Then we have the gamma rays. This one we have seen that they carry no charge, and therefore as they move through electric field, their path will not be changed. They will go undeviated because they carry no charge. And this one is represented in our figure below here. We have the source. This is where we have the radioactive source. It is giving us the three radiations. We are getting the beta, the gamma, and alpha. And as you can see, the beta, which are negatively charged, they are deflected towards the positive plate. And they are lighter, therefore they are deflected. Their deflection is greater. When you come to the negative plate, these are alpha particles which are heavy and they are positively charged. Therefore, they are attracted by the negative plate like this. But when you look at the center one, we have gamma radiations which carry no charge, and therefore they go undeviated. Their path is not changed. We have said that alpha is heavy, and therefore it is very difficult for it to change its path. That is why it is just deflected slightly. But beta, they are lighter, and therefore they are deflected greatly. Then from there we move to the third property, which is ionizing effect of radiation. We start with the alpha particles. This one we have seen that they are heavy, and therefore they walk slowly in the air. And as they walk slowly with a lower speed, then it means that they are going to knock so many molecules of air. And as they knock, they ionize. So in other words, we say that they have a very high ionizing power. They produce a large number of ions as they pass through gases due to their low speed and high charge. Their low speed enables them to be in contact with the target atoms for a longer time. So these are explanations why alpha particles have very high ionizing power. One, we have said it is because of their low speed, and number two, because of their high charge. Then we move to the beta particles. They have low ionizing power, and they produce few ions as they move in gases. Then we go to gamma radiations or gamma rays. Now this one, they have low ionizing power. Then from there we have the assignment. And in this assignment again, it is testing what we have just learned. So make sure that you revisit your video, listen keenly, and make sure that you grasp everything. Then you come and attempt the assignment. So thank you, and let us meet in our next lesson.